All right, I have a joke. This is Mrs. Slater, and the more you have of it, the less you see. What is it? I'll answer that at the end of the class. All right, so we begin the rational roots theorem. First of all, what does rational mean? It is integers, decimals, and fractions. So we're trying to find all of those roots that are integers, decimals, and fractions. So what does this mean? What does the actual theorem mean? It is if a polynomial has these type of coefficients, there is a procedure for finding all rational roots. And you can do it without a calculator. So let's see what we can do here. All right, for example, you take the factors of the last term, which is negative 14. Okay, and we know that there are like 1 times 14, or negative 14, and negative 1 times 14, and negative 2 times 7. But we don't want to write all of those out so specifically. So we're going to make a little shortcut. Underneath here, I want you to put plus or minus 1, because at one time or another, we're going to use 1, and we're going to use negative 1. We are going to have to use plus or minus 2. We're going to have to use plus or minus 7, and we're also going to have to use plus or minus 14. So that covers all of them. And then you look at the first one, it says a coefficient of 1, so then that's going to be factors of the first term, which are plus or minus 1. Now, if we're going to actually find the rational root theorem, what it says is to take the top numbers, which they call C, and the bottom numbers, which they call D, and divide them. So what is plus or minus 1 divided by plus or minus 1? Well, the answer to that is plus or minus 1. What is the division of plus or minus 2 over plus or minus 1? Same exact thing. And as you can already guess, plus or minus 7 and plus or minus 14 are going to also be a part of it. So what this tells you is that these are all 8 possibilities of where a graph could go through the x-axis. Okay? So that's not a picture reference to that. Just an idea. Okay. Now for the next one. Factors of the last term is negative 10. So we can include plus or minus 1, plus or minus 2, plus or minus 5, and plus or minus 10. And then the first term is 1 again. So that's going to be plus or minus 1. Here's our C numbers. Here are our D numbers. And if you divide them, these are all the possible rational roots. Okay? So right underneath that, I know there's a little space here. I want you to go ahead and write a couple things. So to find roots, we've done several things already. But in this particular section, they're not giving us any starting point. So this is going to be our starting point for some cases. And always try to factor first, because that definitely is the easiest way. Okay, and then you go to this method after that. Okay, so the second thing is do the rational root theorem. And after you find one that works, then, so find root, then factor after that. And that is definitely going to make your life easier. If you know already that you need to factor first, and then do the rational root theorem second, that's going to help you out. Okay, so let's go ahead and push pause and get your calculator. Okay, the first example, you can see the last term is plus 2. So we can have plus or minus 2, or plus or minus 1 and plus or minus 2. Again, we can do combinations of them. That's why we have to include them all. Those will multiply to give you 2 and so on. So we have to use all of them. And then the bottom, this is the first time we have a leading coefficient other than 1. So it would be plus or minus 1, plus or minus 3. And if you divide them, you take the top number, plus or minus 1, divide by plus or minus 1. What do we get? Oops. What do we get? We just get plus or minus 1. Okay, and then we take plus or minus 2 divided by plus or minus 1, and you get plus or minus 2. And then we're going to take plus or minus 1 divided by plus or minus 3. Okay, and then that's just plus or minus 1/3. And if we divide plus or minus 2 divided by plus or minus 3, we get plus or minus 2/3. So these are the possible rational roots because of the rational root theorem. Now, how is that going to help us is go ahead and push pause and plug this into the calculator. Okay, so once you have it in your calculator, it should look like this. Okay, and if you look at the graph, it's going to look like this. It's going to look like this. Get rid of that. It's going to look like this. And you'll notice it only crosses one time, and we have a whole bunch of rational roots. That doesn't mean we're going to use them all. It just means that this is a like number bank for ones that could be possible. Okay, so now let's go ahead and go back to our picture here, and I'm going to slide this over so I can refer to it. All right, so of all the rational roots, which ones could be right here between, you know, right there? That's where it's saying that the x-axis is. So it could be a -1/3, or it could be a -2/3. Well, how we can find out really quickly is by doing the synthetic division. And we have 3, 2, 3, and 2. And if I drop the 3 times -1/3 is -1. And if I add 1 to that, that's going, I'm sorry, 2 minus 1 is 1. And then if I multiply that through, it's going to be a -1/3. And then when I add that together, 8/3. And when I multiply that together, I get 8/9, which is not giving me the correct number. So I'm going to go ahead and try the other one, because that I may have better luck with. So 3, 2, 3, 2. And then drop the 3, multiply, so you get -2, which is 0. And then 0 times a -2/3. And then we want to add those together to get 3. So we get 0, and I apologize because that should be 0. And then we add that to get 3. And then if you multiply that to get -2, which then gives you 0. So what that means is that we have a root of -2/3. So we're supposed to have 3. Our roots are -2/3, and we're going to have 2 more. Now we can find the other 2 by now using the leftovers. Like right here, if I put in the x squared, and that's supposed to be an x, and this is nothing, 3x squared plus 3 is going to factor. So if you take out a 3, you're left with x squared plus 1. And then if you use zero product property, x squared plus 1 equals 0, x squared equals -1, and then you take the square root of both sides to get x equals plus or minus I. Okay, so we can fill those in on the list. Okay, so when you see a problem like this, try to judge it with the calculator, and you can kind of get a good start of where to begin. And so yeah, let's go into the next one. All right, so go ahead and do C and D, which would be factors of the last term. So that's plus or minus 1, plus or minus 2. And the next one, we have plus or minus 1 and plus or minus 4. I didn't mean that. So plus or minus 1 because it has a leading coefficient of 1. Oh, good. That little frame left. And then if you're dividing everything by 1, those are your only possibilities at all. Okay, go ahead and go to your calculator and punch that in. Okay, so hopefully you have something that looks like this. That is supposed to be an X, but my cursor was on top of that. And you get this funky little shape, and it looks like we hit 2 times. So of all the x-intercepts right here, that could be one of them, and this other one could be the other. And of all the rational numbers that we have, and it doesn't look like any of them hit right at 1 and right at -2. So we've got to think of some other ways to solve this. Now, I like this example just because it proves that the rational root theorem is helpful, but not in all cases. This right here, let's go back to what we know is the fastest way to go. If I factor it, this would be x squared and x squared, 2 and 1, and then I can put a -2 and a positive 1. And by using zero product property, x squared equals -1, x equals plus or minus I, And then on this one, x squared equals 2, and then x is going to equal plus or minus radical 2. So the degree is 4. We're getting 4 answers, and none of which are rational roots. So sometimes rational root theorem is not helpful. And I want you to realize, like I said before, the hints that you need to go ahead and try to factor first, which this one did, and then go to the rational root theorem. It'll save you some time. Okay, the next one is your turn, so I want you to go ahead and push pause and see if you can get the answer. Okay, and here we go. You've got the last term, which is plus or minus 1, and the first term is 20. So we have quite a few things to write down here. Plus or minus 2, plus or minus 4, plus or minus 5, plus or minus 10, and plus or minus 20. Whoops. All right, so if you divide them, you've got plus or minus 1, plus or minus a half, plus or minus a fourth, plus or minus a fifth, 10th, and 20th. All right, so go ahead and write those down. And let's go ahead and push pause and plug it in the calculator. So once you have them plugged in, you've got 20x squared. Sorry again, my cursor was on the wrong spot. And then so on, 12x minus 1. And then the graph looks like this, where it's coming down, and it looks like it's going right between 0 and 1. We got a lot of things going on between 0 and 1, so we're just going to start from the beginning. Hopefully we get lucky. So 1/2 we'll start with coefficients of 20, negative 30, 12, and negative 1. So if you drop the 20, that gives you 10, and if you multiply that, you get negative 20. And I'm sorry, add that to get negative 20, and then negative 10, 2, and then you are going to get 1, which does give you 0. So yay, we finished on the very first time. And if we're going to put back in the x's, there would be an x squared in that spot, an x, and then nothing at all. So I'm going to go ahead and put plus 2. If I factor out what's in common, I'm left with 10x squared minus 10x plus 1. And then that's going to factor, and no, it doesn't factor at all. So we're going to use the quadratic formula. Okay, and then the quadratic formula will help us find the other roots. So far we've got 1/2, and we need 2 more because there's a degree of 3. And go ahead and push pause and do the quadratic formula. Okay, so we have x equals 10 plus or minus square root of 100 minus 4 times 10 times 1, all over 2 times 10. And you end up getting an answer of 5 plus or minus 15, all over 10 after reducing. So that gives you the other 2 roots. Okay, let's go ahead and go to the next one. You have a C, so we have negative 18. So we have plus or minus 1, plus or minus 2, plus or minus 3, plus or minus 6, plus or minus 9, and plus or minus 18, all over plus or minus 1, plus or minus 2. So in this long list here, we are going to divide everything by 1. So that just is a repeat of the top. And then I'm going to divide everything by 2, which some of it's repeat, so I don't have to write them all down. All right, sorry for that little noise there. So 1/2, and then 2 divided by 2 is 1. We already got that covered. 3/2 is not on our list. And then we have 6 divided by 2. 9 divided by 2 is not on our list, so I've got to write that down. So that covers all our possible rational roots. Again, we don't have to use them all, but if we do have rational root, it's going to be in that list. All right, so go to your calculator. I want you to check that out, and let's see what we can come up with. So we go to y equals. I would just go ahead and clear it all out and just start from scratch. So we have 2x to the 4th, and then I want to tab over in this newer calculator, minus x to the 3rd power, tab over, and then minus 3x, and then minus 18, and then we go to the graph and take a look at that, and you'll see that it's going to go through 2 times. So that's different than what we've seen in most of them. So I'm going to move that over, and it looks like it's in between a -2 and a -1. So I'm going to start with, I don't know, let's see what the other side is. This one looks like it goes right at 2. So I'm going to try that one first, because that seems to be much nicer. So you got 2 and -1 and -3 and -18. Go ahead and push pause and finish that. All right, so go ahead and check your work. You can see that I forgot the 0, so hopefully you caught that for the case of the missing term. And when you get down to the last part here, it's going to factor by grouping. So hopefully you tried that. And then you'll get an imaginary number and 3 halves, so you get all 4 terms. The answer to the question in the riddle at the beginning is darkness. And tomorrow we will pick it up from there and we'll do that last example. So, ta-ta!